All right, today we're going to talk about the similarity of figures and how to find out values in one figure based on just knowing that it's similar to another figure. So there are three main things that we need to deal with. And one we've kind of already dealt with before. It's called the similarity ratio. So you can find the similarity ratio between any two figures, and I'm going to call that the SR, similarity ratio. I'm going to call that the SR, and the SR is always equal to just comparing two corresponding values and then reduce. So in this picture right here, what are the two corresponding values?
6 and 9.
So the similarity ratio of the smaller figure to the larger figure will be 6 to 9, which when I reduce that is what?
2/3.
2/3. Now, here's the cool thing. The perimeter ratio, which is one of the things that we're going to talk about, the ratio between the perimeters is always the exact same as the similarity ratio. So the perimeter ratio, which I'm going to abbreviate PR, is equal to the similarity ratio, which in this case would be 2/3. The other thing we've got to deal with is an area ratio. Now, since areas deal with squared units, before you can do a comparison between two different objects that might have similar areas, you have to know what their area ratio is. And since area is found in square units, the area ratio will equal the similarity ratio, but we're going to square it. So in this case, the similarity ratio was 2/3, but we're going to square 2/3. What's 2 squared?
4.
What's 3 squared?
9.
So the area ratio is 4 to 9. That looks like an A. Let me make that looking more like a 9. So to recap, we need to find the similarity ratio first. Then after we find the similarity ratio, we're going to be using that similarity ratio to calculate an area ratio. And then after we know what the area ratio is, then we can probably go ahead and set up a proportion to solve the problem. So let's see what I'm talking about. Okay, here's a problem where we've got two similar polygons that have corresponding sides in the ratio of 5 to 7. Now, in the ratio of 5 to 7, what do you think the 5 represents, the smaller or the larger? And then the 7 represents the larger. Now, it's going to ask me a trick here. It's going to ask me, what is the ratio of the perimeters from larger to smaller? So the first thing I need to do is I need to do a sim ratio of larger to smaller. What would the sim ratio of larger to smaller be?
7 to 5.
7 to 5. And then what's the perimeter ratio going to be? Now remember, the perimeter ratio is exactly the same as the similarity ratio. So this is going to be the same thing as I just wrote. So it's going to be what? 7 to 5. And then the area ratio is equal to the similarity ratio squared. So that's 7 to 5 squared. What does that come out to be? 49 over 25. So the first thing that's very important is you need to be able to calculate perimeter ratios and area ratios from knowing how the two figures are similar. Does everybody feel pretty confident about that? You may. All right, so knowing that, we move on to a problem. So now we're going to find the area just knowing something about similar figures. So I'm going to go ahead and tell you up front, these two pentagons, they're similar. And so, since I know they're similar, I can create a similarity ratio because I've been given the value of two corresponding sides. So step one is find your sim ratio. So SR is equal to, what would the SR be in this case?
4 to 10.
4 to 10. Is that reduced? Not 1 over 5, 2 over 5. So let's go ahead and reduce it to 2 over 5. All right. So step one, I have found the sim ratio. Step two, since I am working with areas, I can't use the similarity ratio because the similarity ratio isn't an area ratio. I'm going to have to calculate the area ratio. So I need to find the AR. Do you remember what the relationship between the AR and the SR is?
SR squared.
SR squared. So SR squared is going to equal, in this case, 2/5 squared. And what would that be?
4 over 25.
4 over 25. Now, once I know the area ratio, if I have area values of one figure, I can proportionally set up something to find the area value of the other figure. So step 3 is setting up your proportion. You have to use the right ratio to set up the proportion. If I'm working with perimeters, I'll use a PR. If I'm working with areas, I'll use an AR. And then later on in chapter 12, we'll be working with volume, and we have to be able to find the VR. But that's just foreshadowing. Dun, dun, dun. All right, so what was my area ratio? 4 over 25. And now, that means that for every 4 units of area the smaller figure has, the larger unit is going to have 25 square units of area. So what was the area of the small one? 27.5. And we don't know the area of the larger one. Do we have any way we can solve this proportion? How? Cross multiply. Kaboom, kaboom. So when I cross multiply, I get 4x is equal to 25 times 27.5, which is 687.5. And then how would I solve for x? Divide by 4. So that's going to give me 171.875. And now I just need to match this answer with multiple choice. Which one of these is the closest? C, 172. So your correct answer is C. That's really close to 172 square centimeters. So what are the steps? Similarity ratio, area ratio, proportion solve. Do we feel good about that?
No, I honestly have no idea.
Okay. Do you understand how I found the similarity ratio?
Yeah, I get it all, but it's not retaining in my brain. Like, I know how to do the different parts.
Well, let's practice one then.
Wait, do you always put like the smaller figure over the larger figure? Or
I do when I'm setting up the ratios.
It doesn't matter as long as you stay constant.
As long as you're consistent, it doesn't matter. So I could have done 25 over 4, but then this would have had to have been x over 27.5. When you cross multiply, you'll still get the same answer. All right. The scale factor is the same thing as the similarity ratio. Two similar parallelograms is 3 to 4. The area of the larger parallelogram is 96. What's the area of the smaller? See if you can't work that one out real quick. So I'm wanting to find the area of the smaller parallelogram. So remember, step 1 is to identify what my similarity ratio is. So in this case, what is the similarity ratio? 3 to 4. Similarity ratio and scale factor are the exact same thing. They're just two different ways to say it. Step 2, I need to find, since I'm working with area, I can't use the similarity ratio. I need to find the area ratio. So Maddie, how do you convert a similarity ratio into an area ratio?
You square it.
So what's 3/4 squared? I love the way you did that. That's exactly how you're supposed to do it. So you've got the similarity ratio is now 9 to 16. I now know, the area ratio is now 9 to 16. I now know what my AR is. And that is half of setting up a proportion. So you just rewrite that down to set up your proportion. And in setting up my proportion, do you think the 9 represents the smaller area or the larger area?
What was the question?
Do you think the 9 represents the smaller area or the larger area?
Smaller.
It represents the smaller area. So what area do I have in my problem?
The larger.
So that means the 96 goes where? In the top or the bottom? In the bottom with the other larger area. And now it's just a cross multiplication problem. 16x is equal to 9 times 96, which is 864. And then I divide both sides by 16, and I get 54. Yay, Christmas. You could just put it all on that table right over. Actually, you can just put it on that back table. Yep. That'll make it easy for you. All right, so that's the answer. 54 square inches was the smaller area. So, some steps that you have to remember, but not really a complicated process. All right, let's see what happens when we turn it into a word problem. During the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry, a worthy cause. Next summer, the city will let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. So how many bushels can the students expect to harvest next year? So that's kind of a tricky way to say that the sim ratio is equal to 1 to 2.5. Because if I'm going to give you 2.5 times as much, then I just take 1 and multiply it by 2.5, and now that's my new value. So that's the sim ratio. How do you turn that into an area ratio? Square it. So what is 1 over 2.5 squared? You were right. 1 over
6.25.
6.25. So that's the first number in my proportion. So now we're wanting to figure out how many bushels that I'll be able to make. So I harvested 13 bushels the first time. Now, was that with the smaller plot of land or the bigger plot of land? So the 13 will go up here, and then the x will go here. And so this is a real simple cross multiplication problem. X is just going to equal 13 times 6.25, or 81.25 bushels. So just by giving a piece of land 2.5 times as much, I can get a whole lot more bushels. So how many bushels if we round this off? You can't really have 81.25, so I guess that would be 81 bushels. That's a pretty good return, though. So that's just setting it up using a word problem. Similarity ratio, area ratio, proportion solve.
Do we get the harder parts that might include?
Yes, ma'am.
So when you're like simplifying for an area ratio and you square it, if like the thing that you get can be simplified, you just leave it unsimplified?
Well, usually if you start out with a simplified similarity ratio and then you square those terms, you won't be able to simplify the area ratio because they won't share any common factors. So if I start out with 2 over 5, I get 4 over 25. 4 over 25 can't be simplified. But if I started out with 4 over 10, I'd get 16 over 100. 16 over 100 could be reduced. So you reduce. You always reduce at the earliest stage, which would be right here.
If it was 2 over 4?
If it was 2 over 4, I'd reduce it to 1/2. Before I do any calculations, that'll just make the math easier. Okay? So, scale factor of 2 dimensions of 2 similar pieces of window glass, 3 to 5. The smaller piece costs $2.50. How much should the larger piece cost? And usually pieces cost based on square feet, or square, in this case, I don't know. It's an area estimate. So we're going to have to find the area ratio. So go ahead and solve this problem for the new value. Remember, the smaller piece is $2.50. How much should the larger piece cost? So generally when you're buying carpet or you're looking at windows or anything that's like a dimensional thing, it's by area. All right, so let's go ahead and compute the value of this. The first thing I'm going to do is I'm going to find the similarity ratio. And the similarity ratio, or the SR, is just going to be 3 to 5. That's the smallest to the largest. The area ratio will be the square of that. So I'm going to take 3/5, square it. That's going to give me 9 over 25. And 9 over 25 is what I'll use to perform my proportion. So 9 over 25 is equal to, now remember, I have the smaller piece. So that's $2.50 over x. 9x will equal 25 times 250, which is 6250. And then I'll just divide that by 9. And I get, I'm going to call it $6.94. $6.94. So this seems reasonable because this is a bigger piece of glass and it's more expensive than the smaller piece of glass. All right. So the other thing we can do is we can go back and we can find the perimeter ratios, or we can find perimeters. So how do you go backwards? How do you start out with knowing the area of two figures and get to the perimeters of two figures? Well, if my AR is equal to 50 over 98, which, by the way, that would reduce to 25 over 49, then my similarity ratio is just going to equal the area ratio, but I'm going to take the square root of it. That makes sense. If I square this to get that, then I should have to square root this to get that. So in this case, it'll be the square root of 25 over 49. To take the square root of a fraction, you just square root the top, square root the bottom, and simplify if you need to. All of these are going to come out to be even though, so you won't have to worry about any crazy simplification. So now that I know that the perimeter rate, the similarity ratio is 5 to 7, the perimeter ratio is also equal to 5 to 7. Let's see if I can do a P. Perimeter ratio will equal 5/7. So what is the scale factor? 5/7. What is the ratio of the perimeters? Same thing. Scale factor and perimeter ratio are going to be equal. So if I tell you the areas of two similar rectangles are this and this, what is the ratio of their perimeters? Now notice that they have larger to smaller here. That's fine. You can still set up the ratio any way you want to. So the area ratio is going to equal 1875 over 135. And so what I need to do now at this point is I need to see if that fraction will simplify. So 1875 divided by 135 should simplify to 125 over 9. So the similarity ratio will equal the square root of that. Which is equal to 5 to 3. So the ratio of their perimeters is 5 to 3. All right. So hopefully you'll be able to work these problems now. You'll be able to get the correct answers, and we'll go over them in class tomorrow.